Hello everybody, and we are going to talk about Rails caching, specifically what are the differences in the Rails 4 regarding the caching, and well, I hope it will be helpful. Someone said to me in the corridor that up until now there wasn't much technical talks. This will be a technical one, even though not a very advanced, but an introductory. So, my name is Vitaly Kushner, and I'm programming from mid-80s. I started working in beginning of 90s and doing Rails since 2005. I founded Rails. Actually, we incorporated in 2008, and I co-authored the Rails 4 Way book together with Obi Fernandez. The Rails 4 Way is, I think, is the best opinionated Rails reference book. I have a coupons for this conference. Of if someone wants, they can come to me after the talk to get coupons for a discount. Okay, so Rails is a Rails consultancy. We build complex web applications for our customers since 2005, and we incorporated in 2008. We have a blog. On the blog we will post transcript of this talk, and when the video will be available, we will post it as well. Oh, and by the way, next week I will be updating the caching chapter in the Rails 4 Way book with the content of this talk. We don't have much time, like 28 minutes left, so I will try to not get too deep into things. Let's start right away. What is caching? Caching is transparently storing data so that future requests for the data can be served faster. And there are two keywords here. One is transparently, and it means that the client that requests the data shouldn't care if the data comes from a cache or directly from the source. And the second keyword is faster, and it's obvious there is no sense caching something if it doesn't make things faster. Caching is an essential component of any high-performance Rails application. All of the big Rails applications that you hear about, they all use caching to one degree or another. A word of caution about caching. If you introduce caching into your application too early, or if you do not watch for a warning signs, you can get yourself into a very bad situation. For example, if you have a slow action that takes several, seconds to complete, for example, user profile, because you have 123 queries on the page, and you don't feel it usually because you cache those profiles, so only now and then when one of the profiles changes, you get the long request. It doesn't show too much on the logs, and people might not be complaining much, but next time you restart your cache store, for example, to increase its capacity, you will lose all the cache data, and so for a while all the profile requests will be going to the source, to a Rails application, taking several seconds to complete, so it's a very good chance your application will crash or get to a standstill, and users will not be happy. To protect against this, you need to watch very closely slow logs, slow queries, slow actions. In short, New Relic is your friend, and if you see something is slow, beware that caching is not the solution, because you first of all need to make sure that nothing is so slow that without caching your application crashes. Okay, now let's look at how a typical web browser requests goes to our Rails application and where we can cache stuff. We start within a browser, and browser has its own cache. Then we might get into the proxy server, like your corporate proxy or ISP proxy. Many of them have caching as well. You might go through a CDN if your application uses a content delivery network, like just a second, like Akamai or Amazon CloudFront. And since we are talking about Rails application, the way Rails works is that you have multiple application servers, and in front of them there is a reverse proxy server, being it Apache, Nginx, Varnish, or whatever else. So you have this caching reverse proxy, which also might have a caching in it, and only then you get to actual Rails application servers, which also can have caching enabled inside. Rails application is of course a rack application, so we have a rack stack, and there are a couple of components that are relevant for caching in our rack stack. Those are rack cache, rack conditional get, rack etag, and application itself. Rails application also can have access to a cache store of some kind. We will talk about it in a moment. So inside of Rails application, we will just, one thing to note is that the farther from the browser we go, the slower the request will be. So if we can cache closer to the browser, that's the best caching there is. Now, but we will start from the end. When you got into your application, Rails application, you have actually four kinds of cache. You have page cache, action cache, fragment cache, and raw access to Rails cache for your data. Page cache and action cache were deprecated in Rails 4. They were extracted into separate gems, and the use is discouraged. The reason is, for example, page cache is almost never used in any interestingly complex Rails application for several reasons. You almost never can do it because your pages change, the dynamic pages. If you have a lot of static pages, just use some CMS like WordPress and be done with it. And also in a multi-node setup, you cannot easily expire page caches. Page cache works by writing an actual content of the page into a file on the file system, so that the next time a request comes, now the file is at the same place where a web server will look for a static file with the same URL. So next time request comes, they can just pick up the file in the file system and bypass Rails application entirely. The problem is that, as I said, when you have multiple servers running Rails application, you cannot expire cache on all of them unless you are using distributed file system, which is a bad idea in itself. Action caching is just a special case of fragment cache. It used just an around filter that was storing the content of the action as a fragment. As well, it was removed into a separate gem, and it is not needed. So the only HTML caching available in Rails 4 is fragment cache. Now all of those caches, at least not all of them, action cache and fragment cache, they build upon a raw Rails cache API, which is just a generic API to cache anything with any key. It's just key value store. To enable it in your application, you first of all need to enable it in configuration, which is by default enabled in production environment. But if you are playing with your caching in development environment, you might have to enable it, or you can create another development with caching environment for when you develop and test your caching code. When you store something in a cache, where does it go? It depends on what cache store do you use. Rails has several cache stores available: file store, mem cache store, memory store, null store. Now, file store is the default. It will store every key as a file in a file system inside TMP directory. Memory store will use just a hash inside in the memory inside of a Rails process. And null store will not store anything. It will just throw all of your data away. You can use it to debug some of the code, caching code, when you want to make sure that there is no actual value available. File store and memory store, they have the same problem with as page caching. You cannot invalidate data on another node. So memcache store is probably the store that you're going to use. Usually when someone is talking about Rails caching, they usually use memcache store. To configure a store, you go to your config application RB and set a cache store option. If you are going to use memcache store, you will have to add Dali gem to your gem file, because this is the gem that implements memcache API that is used by Rails. How do you use the cache? The interface is actually really simple. You can write key value and then fetch by the key. If you can use symbols and strings interchangeably as your key, and data can be anything. Any Ruby object will be stored. You can also use compound keys consisting of an array or a hash of different things, and actually just an array, and it will work as well. Internally, Rails will transform this key into a string, because on the low level everything still is a string when you access a caching store inside. And the write operation has several parameters available. You can define namespace, which is used to create a namespace inside of a caching store. It is useful when you are using external caching store like memcache that you are using together with another application. So by default, your application name and environment is used as a namespace in this case, but you can change it if you want. And compress allows you to compress data. If you have data that is big and easily compressible and a slow network to access your caching store, you might want to enable compress. Compress threshold is the minimum size of the data that that is needed for compression to kick in. Below this size, compression will not be used. Unless exist is a simple option. If it's true and key already exists in a caching store, then the new value will be discarded and will not be stored. And expires in is a number of seconds after which the value will be discarded automatically. Now, the usual pattern when you want to access cache is that you want to try cache, and if it's not available, then you have your way of computing the value from scratch, which is usually slow, and that's the reason that you are using cache in the first place. And once you compute it, you usually want to store it back into the cache so that next time you will not have to do it again. And this pattern of use is done really simply with the fetch call using a block. When you provide the regular fetch call and then a block that will compute the value if the data is not available. In this case, the block will run, its value will be stored in the cache and returned to you. Note an interesting option. If you say that your value expires in 5 minutes and the value is used frequently by multiple servers, like in any real Rails application, you might have a condition when a key expired and then all of the application servers tried to access it so that it's not there, then everybody tried to recompute it simultaneously. To protect against it, there is a race condition TTL value, which is for how many seconds other servers can still be using the old value while one of the servers computing the new one. So when value expires, the first one to come and ask for it will get the new bag and will start recomputing it. The rest will still get the old value for this number of seconds. So this more or less concludes how do you access Rails cache. It's, as you can see, really simple, and you can cache whatever you want, like expensive computations, content of external services calls, etc. Now, fragment caching, as I said, it's built upon the same interface, and it allows you to cache parts of your HTML pages. If you've seen any real Rails application in New Relic, for example, you will see that rendering takes quite a bit of time. Not only database takes time in Rails application, rendering takes a lot of time as well. So fragment caching allows you to save a lot of time here. And interface again is really simple. Assuming this is a HAML code, you call cache, provide it with the key, and then there is a block that does the rendering or HTML code that you want to use. Now, it's really simple. If there is no such key in the store, then there will be rendering and content will be stored in the cache. If there is a content in the cache, it will be used directly. Now, the problem is what happens if my post changes, because my key is just post ID. If post title is changed, there will be a stale page. So we can go the somewhat easy way and say that we cache it for 5 minutes, and after 5 minutes it will be regenerated. For some applications this might be okay. For example, for parts of your page that say top posts or favorite posts or stuff like that, you can regenerate it once in a couple of minutes. Another way is to expire fragments. For example, in post update action, I can call expire fragment post with an ID. But this is a bad idea, because if we go expiring route, we will have to call expire fragment for every possible fragment that can depend on a post in every possible place that post is updated. So it's probably a really bad idea, and we are not going to discuss this way of working with cache at all. Instead, Rails provides a smarter way of using smart cache keys. For example, like this. What happens here? We can see which actual key is used by calling active support cache expand cache key function. Whatever we pass to it, we get a string that Rails will use as a cache key. In this example, we can see that we have top, which is the first symbol, then posts, which is name of the table, and then 1, which is ID of the post, and then some long number. This long number is just a timestamp of updated at of the post with nanoseconds, the full timestamp. And so whenever the post is updated, this key will change, which will automatically invalidate my cache. It will not actually remove the content from the cache, but next time when I will try to fetch it, I will go with the new key, find nothing, and regenerate the content. Now, we do not need to remove data from the cache using this, because memcache, as many other caches, will just set a preset amount of memory for the cache and discard keys that were used long time ago. What can we do if we want to cache something using a collection? For example, recent items. Again, we can use expires in 5 minutes, which is reasonable and can be okay for many applications. Or we can provide a cache key function on the active record base, which will return string, which is name of the class, maximum updated at, and count. We need count so that when some records are deleted, the key will change. And of course, if we update any of the records or create a new record, the key will change. And then we can use it like this: cache recent item, partial, and collection. We have another problem here though. What happens if I change my partial? Because changing the partial will not change the key here, or so it seems. In older version of Rails, you had to add versioning to your caching keys, and so every time you changed a partial, you had to increment or change the version of the key. And this is a problem because it's really easy to forget, and there are like maybe nested templates inside of nested templates that are changed, and you need to propagate versioning all the way up to the top cache call. Really inconvenient. So in Rails 4 introduced something called template digests. Now a template digest is a hash, is a long string, is an MD5 or SHA1, I don't remember. I think MD5 of all the template and its dependencies. So if you have a template and another template is rendered from it as a partial, change in any of them will change the template digest. And this template digest is automatically appended to cache keys when you use cache from inside of a template. Now, there might be a problem sometimes when Rails cannot understand template dependencies. For example, if you're rendering something from inside of a helper, Rails cannot know about the dependency. In this case, you need to tell Rails inside of a comment inside of your template that you have template dependency and the name of the template that you depend on. Now, hashtag space template space dependency column, this is the regular expression that it's looking for. So it has to be exactly like this. And if you do this, Rails will do the rest and will automatically invalidate your caches. So what about nested fragments? For example, let's say we cache post template that has comments, and we cache each and every of the comments as well. Now, whenever the comment changes, we want to invalidate the post as well. Now, there are two ways to do that. We could supply all the comments in an array to the first cache call, so we will have post and all the comments, and we will have a really long cache key. Another option, I think it's a better option because it doesn't require you to remember to do it every time, is to make sure then whenever a comment is changed, updated at of its post is updated as well. We can do it easily by adding touch true to the belong to association on the comment. So each time when we create, delete, or update a comment, post will have its updated at changed, and so all the cache keys will change as well. Now, we are caching the rendering, but we also want to cache or spare the database query, because we don't want to go to the database if we have cached value. If you write data like your code like this, there will still be a database query even if you have the cache. So instead, it's better to move your queries inside helpers, helper methods, and access them from inside the cached fragment. So if the fragment is cached, it will not be executed, so the helper will not be executed, and you will not have the database query. Another option is you can check for existence of a fragment and create a code depending on that. So back to the big picture. As we said, let's say we did all the caching we could inside of the application. Now we want to enable HTTP caching, which is caching outside of our application. Now, HTTP caching is defined by HTTP standards, and it works with several HTTP headers. The most important ones are last modified, etag, and cache control that are set on the server side, and if modified, since, if none match, and cache control set on the client side. We need to run faster. Okay, so let's first look at the rec stack. Rec etag is a middleware that will look at your application response. If you didn't set the etag header, it will MD5 the content of your response and set it as the etag. Really simple. Conditional get, what it does is that when it gets response from your application and it looks at the request, if last modified from your application matches the if modified since in the request, and your etag matches if none match in the application, in the request, then instead of returning the content that your application just produced, this middleware will return HTTP code 304 not modified. Even though you did produce your response, there is no need to send it back to the browser, because someone in the middle already knows the exact response and you don't have to send it again. Now, rec cache is an HTTP standard cache that lives inside of your application. It is disabled by default, but it is really easy to enable by configuration value in environments production. You just need to uncomment one line and add rec cache gem to your gem file. It will do all the same things like HTTP caches at the ISP level will do, but inside of your application, really handy, and you can test locally all your caching scenarios. How do you provide custom etag and last modified? There is a call with fresh when that you can call from your action and provide etag and last modified, and public true or false. Public true says that the content can be cached to anyone, and public false says that just a specific client, we can cache it for this specific client. For example, browser will cache this, most of the HTTP level caches will not. Another useful thing is a controller level function etag, where you can provide additional information that will be taken into account when computing etag value. By the way, whatever you provide to the etag, it will be all bundled together, and MD5 function will be used to produce the actual etag. Another option is stale function, is when you want to conditionally execute some of the code when the application is stale. It means we do not have the cache. Now, when you provide just an article, instead of providing etag and updated at, those functions will just take the article's cache key and updated at field for that. Another thing is that we can change the cache control header of HTTP response. We do that by using expires in call, and we can provide a time for the expiration, public true or false, and must revalidate true or false. Must revalidate when it's true. When cache is stale, the cache store must request application again. Without it, client can direct cache to return stale cache values, and with this setting it cannot. Every cache will come back to the application. Expires now makes sure that it's not cached at all. So cache control by default is max age 0, private, must revalidate, which means it will not be cached at all. For static files, it is public and must revalidate, which allows caching, and it is a good idea to set max age for something long for static assets. Okay, we don't have, okay, 2 minutes. So there are several problems with caching. Common pitfalls that I want to show you. First is that what happens when we change template and we use that? The problem is that our template changed, or more importantly, we changed CSS file, but our template didn't change, our record didn't change, so the request for the show action will return not modified, which includes reference to the old CSS file. What happens if browser now tries to retrieve the old CSS file? It's not there, especially if you're using Rails assets pipeline, because your CSS file has the content hash in the name. It's changed, so it's not there. You will have broken pages. One way is cache versioning all over again. You can have itac v1 in every place, and whenever you think that something changed, you can go and increase it. Probably a better idea will be to set it from environment variable, like itac extra. On Heroku, then you can increase it or change it on every deployment, like Heroku config add itac extra date, and date time of just this second, and on every deployment your caches will be invalidated. Might not be again a good idea, because then you will have a brief time when your application works really hard. There are two environment variables supported by Rails, which is Rails cache ID and Rails app version. If you change any of them, all the Rails cache will be invalid. All of it will be purged, and effectively purged, because you will not be able to access old values. And again, use it when you need it, but be careful, because your application might be working too hard. Another thing is protect from forgery. If you have a page that is cached and it has protect from forgery meta parameters inside of it, the parameters might change because user did re-login, or log out and log in back, or its session was changed for any reason, and any form submit from this page will fail. What you can do is you can provide a tokens request that will just return JSON of forgery protection params. It is really important to authenticate this request, because if you don't do it, it's not a good idea. And once you have this JSON request, you can use this simple JavaScript to reset the values inside of the page from the response of this JSON request, and it will start working again. Okay, I think we are done.
Thank you very much, Vitaly.